In this video, we will discuss number 6, which begins with the initial steps for any research project. These signature steps, which includes the topic, the research question, the hypothesis, and the objective. So the topic here is DSC Math 121 student. Now the research question here is, what is the correlation between time spent practicing and score? So here you've got two variables, time spent practicing and score. And the question is, what is the correlation between the two? How are they correlated? So to hypothesize or to claim a response for such a question, for example, the correlation between time spent practicing and score is weakly positive. So the researcher could claim strongly positive, weakly negative, strongly negative, or no correlation, or perfect positive or perfect negative. But due to experience, due to past research, or for whatever reason, the researcher claimed that there is a weak positive correlation between time spent practicing and score, meaning when time spent practicing increases, your score may increase slightly, okay, or it may be affected by a small percentage, okay, meaning that there are other major factors affecting your score, not just the time spent practicing. So according to what the researcher is saying, time spent practicing does not play a major role in your score. That's why he claimed a weak positive. So the objective now is to determine the correlation between time spent practicing and score. So we need to update this a little bit here. The correlation between time spent practicing and score. That is the objective, not the average. So this is a little typo right here. Let's update this. Right, to determine the correlation between time spent practicing and score of Math 121 students. So now data has to be collected to fulfill that objective and also to test that claim. So the data collected, here it is presented in this table. 3 students were interviewed. One said they studied for 7, they got 15. Another said they studied for 9 hours, they got 45. Another said they studied for 15, they got 35. So you can actually sense there is a slight correlation between the two as score increases. As time spent practicing increases, score seems to be increasing. So this correlation now can be measured by using this formula. Is called Pearson's correlation of rank. Pearson's correlation coefficient. Okay, not rank. Rank is Spearman's. Pearson's correlation coefficient. So let's look at the table that will break down this formula to measure the correlation using these data values that were collected. So now would be a good time to take out your pencil, your calculator, and your paper and to go through this table with the video. So there are 6 numbers that have to be calculated. First number, n times the sum of xy. So whenever you see sigma, you must find what is to the right of sigma first. So we have to find xy first before we find the sum, then multiply by n. Xy means x times y, 7 times 15, 9 times 45, 15 times 35, 105, 405, 525 respectively. And then these values will add it up to get 1035, and we will multiply by 3. 3 is n, and then we get 3105. So that's the first value. The second value is the sum of x times the sum of y. So we need the x's for 7, 9, and 15. We find the sum, which is 31. The sum of y, we need the y is 15, 45, and 35. We find the sum. Now we can multiply 31 times 95. That's the second number, 2945. The third number, n times the sum of x squared. The sum of x squared, we have to find the x squared first before we find the sum. 7 squared, 9 squared, 15 squared will give us 49, 81, and 225 respectively. Then we add this up to get 355. Then we multiply by n, which is 3, to give us 1065. The fourth number says in a bracket to find the sum of x and then square it. We have found the sum of x to be 31 already. So we simply square 31 and then to get 961. To get the fifth number, this n times the sum of y squared. So we need the sum of y squared before we multiply by n, but then we need the y squares before we find the sum. So we have to find the y squared, 15 squared, 45 squared, 35 squared, 225, 2025, 1225 respectively, and then we find the sum to give us 3475. Then we multiply by 3, which is n, to get 10,425. And then finally, to the sixth value, in a bracket, the sum of y all squared, we have already found the sum of y to be 95. 95 squared will give us 9025. And here we have found the 6 numbers. But before we substitute into the formula, we can break down those 6 numbers to 3 numbers. Okay? We can call them A, B, and C. So A is the first minus the second. 3105 minus 2945 to give us 160. The third number B, the fourth minus the fifth. The third minus the fourth, sorry, which is 1065 minus 961, it goes 104. And C now is the fifth number minus the sixth number, 10,425 minus 9025 to give us 1400. And then we can now substitute, instead of substituting 6 numbers into the formula, we can now substitute 3 numbers into the formula. 160 divided by the square root of 104 times 1400. Multiply 104 times 1400 to give us 245,600. Then we square root this to give us 38.576 and divide 160 by 381.576 to give us a correlation, Pearson's correlation coefficient of 0.419, which appears to be less than 0.5. So it appears to be that the claim seems to be true, that appears to be true that the correlation is weak, positive. Part B, 1 says to use the correlation R to calculate and interpret the coefficient of determination. So to do that, we square the correlation and multiply by 100%. So 0.419 squared times 100% will give us 17.58%. So therefore, now 17.58% of the variation in score is due to time spent practicing. So part 2 now is saying, is the claim true? Give a valid reason for your answer. Well, the claim is true because the correlation calculated is actually 0.419, which is weak positive because 0.419 is less than 0.5 and it is positive. Now, part C says to use the results in part A, not part C. Part A to determine the gradient and the y-intercept of the equation of the line of best fit, the linear regression, and write the equation in the form square is equal to m times always plus C. Now, here's the formula for m and here's the formula for C. M is actually A divided by B because A is the numerator of the formula, the Pearson's formula, and B is that second number we calculated, which of course is the third minus the fourth. So that the gradient is simplified to 160 divided by 104, which is 1.54. Now C now is the sum of y minus m times the sum of x over n. We found the sum of y to be 95. We just calculated the sum of x to be the average, the gradient to be 1.54. And we know the sum of x we calculated to be 41. So it's 95 minus 1.54 times 41 divided by 3, which is 47.26 divided by 3, which is 15.75. So please take out your calculator to actually do these calculations to participate in the video. So now we can write out the equation y is equal to mx plus c. We have calculated m and we have calculated c. So we simply substitute score is equal to 1.54 times hours plus 15.75. So this is the equation that we have modeled using the data that was collected. Now we can use this equation to estimate the hours for a score of 32. So we substitute 32 in the place of score and we rearrange the equation to solve for hours. We subtract 15.75 on both sides. So 32 minus 15.75 will give us 16.25. And then we divide by 1.54 on both sides to cancel out 1.54 because it is multiplying to hours. So 16.25 divided by 1.54 will give us 10.56. So hours is equal to 10.56 if you want a score of 32. And now part E now says use the equation to estimate the score for 10 hours of study. So since score is already the subject, so we don't have to rearrange. We simply substitute 10 in the place of hours and we multiply by 1.54 m times hours, and then we add 15.75 to get a score of 31.15 for a time of 10 hours. So here we are using the model to forecast